Yeah, in this video, I will explain what is cross product of two vectors. There are plenty of questions in J main and J advanced related to dot product and cross product of vectors. Vector algebra has a very good weightage in J main as well as J advanced exam. So I'll explain very briefly that what is right-handed system of vectors. What is right-handed system of vectors? Right-handed system of vectors means you take, for example, you take three vectors. Okay, right-handed system of vectors. Well, you see that this is origin, right? And this is vector A of A bar, A of A bar. And this is another vector B of B bar. Okay, all right. And this is a vector C bar. It's not necessarily perpendicular, right? Now you see that when you are viewing from the top of the vector C, the angle of rotation from A bar to B bar, this is anti-clockwise direction, right? This is an anti-clockwise direction. Should not exceed 180 degrees, should not exceed 180 degrees, should not exceed 180 degrees. Then we say that A bar, B bar, C bar form a right-handed system of vectors. Form a right-handed system of vectors. Like this. This is C bar vector and this is A bar vector, right? Or this is A bar vector, this is B bar vector, this is C bar vector. Rotation of angle should not exceed 180 degrees in anti-clockwise direction, right? In anti-clockwise direction, like this. In anti-clockwise. Then we say that A bar, B bar, C bar form a right-handed system of vectors. That angle should not exceed 180 degrees. This belongs to 0 to 180 degrees in anti-clockwise direction. All right, like this direction, anti-clockwise direction. Then we say that A bar, B bar, C bar form a right-handed system of vectors. And this is known as a right-handed system vector triode. This is a right-handed system vector triode. If it is not right-handed system, then it is called simply left-handed system of vectors. Now you see that, here you see that this is in right-handed system of vectors because anti-clockwise direction. You see the angle of rotation from A bar to B bar, angle of rotation in anti-clockwise direction. Here you see that this is in clockwise direction, in the clockwise direction, that A bar, B bar, C bar. So here A bar, B bar, C bar form a RHS. Right. This is right-handed system. Here A bar, B bar, C bar form a left-handed system of vectors. All right. What will happen? You see that when A bar, B bar, C bar form a right-handed system of vectors, right? A bar, B bar, C bar form a RHS. This is RHS. It is a right-handed system of vectors. You are starting from A. Now you can start from B also. You can start from B. Okay. You take the vectors in anti-clockwise direction. Then B bar, comma, C bar, comma, A bar also form a right-handed system of vectors. Now start from C. C bar, A bar, B bar also form a right-handed system of vectors. Well, if we interchange any two vectors of one system, then the system will become reverse. If we interchange two vectors in RHS, then it will become LHS, right? Well, so here you see that B bar, comma, A bar, comma, C bar form a LHS. This is an LHS, left-handed system of vector triad. You can see here, you see B bar vector, A bar vector, and C bar vector. This is a left-handed system in clockwise direction. And if you replace any vector by negative vector, then the system will be changed. Minus A bar, B bar, C bar will become left-handed system. Well, here I think I can explain here. You see that this is A bar minus A bar vector. This is minus A bar vector, right? Okay. Minus A bar, B bar, C bar form a left-handed system of vectors. Well, if any vector of RHS is replaced by negative of that vector, then the system will be reverse. Here is an example that, so here this is an RHS system. If I take a negative vector, that A of minus A bar, this is in opposite direction. Okay. Now you see that minus A bar, B bar, and C bar in clockwise direction. They are in clockwise direction. Minus A bar, B bar, C bar. So therefore, they form a left-handed system of vectors. Now, without having the knowledge of RHS, we cannot define cross product of two vectors. Now, how do we define cross product of two vectors? Well, if you consider a vector A bar and a vector B bar making some angle theta, and consider a unit normal vector to A bar and B bar. Remember, consider a unit normal vector or consider a unit vector perpendicular to both A bar and B bar, right? So here n cap is perpendicular to A bar, comma, B bar, and this is a unit vector. And also that A bar, B bar, and n cap form a RHS, right-handed system of vectors. Well, now we define the cross product of two vectors. Now we define that cross product of two vectors, A bar cross B bar equal to modulus of A bar into modulus of B bar into sin theta into n cap. This is an important. Here we are multiplying n cap to the scalar, therefore it is a vector quantity. So cross product of two vectors is a vector. Remember, cross product of two vectors is a vector. Dot product of two vectors is a scalar. Well, right? Remember, we apply this formula when A bar, B bar, and n cap form a RHS. What is n cap? N cap is the unit vector perpendicular to A bar as well as perpendicular to B bar. All right. And that A bar cross B bar is equal to 0 bar if either A bar is 0 bar or B bar is 0 bar or angle between A bar and B bar is either 0 degrees or 180 degrees. That point you can see here that if one of the vectors A bar and B bar is null vector or A bar, B bar are collinear vectors, then A bar cross B bar is equal to 0 bar. Well, so once again, I am telling that A bar cross B bar equal to mod A into mod B into sin theta. Theta is the angle between the vectors into n cap. What is n cap? N cap is the vector perpendicular to A bar and B bar. Perpendicular to A bar and B bar. So once again, I'll explain that this is A bar vector and B bar vector. This is B bar vector. This is A bar vector. And this is perpendicular to A bar and B bar. Perpendicular to A bar and B bar. You see, this is perpendicular to A bar and B bar. Well, so now we are going to explore what are the possible, you can say, deductions from this definition of cross product of two vectors. So once again, I'm telling what is n cap. N cap is nothing but the vector, unit vector perpendicular to A bar and B bar. So this is the definition of that A bar cross B bar is equal to mod A, mod B, sin theta and n cap. Done. Now taking modulus both sides, right? Mod A keep as it is, mod B keep as it is, mod sin theta keep as it is. But what is modulus of n cap? Modulus of n cap is nothing but 1, right? So here modulus of n cap equal to 1. Well done. Therefore, now substituting this quantity equal to that modulus of A bar cross B bar here. So we got that A cross B equal to modulus of A cross B dot n cap. Remember, here I am writing that again A bar cross B bar equal to mod A, mod B, right, sin theta into n cap. But this is equal to modulus of A bar cross B bar, isn't it? Into n cap. So we got that n cap equal to A bar cross B bar by modulus of A bar cross B bar. What do you call this? This is the unit vector perpendicular to both A bar and B bar. So the unit vector perpendicular to both A bar and B bar is A bar cross B bar by modulus of A bar cross B bar. This is the unit vector perpendicular to A bar and B bar. Well, this is a very, very important concept. Done. So now, what is the vector perpendicular to A bar and B bar? What is the vector perpendicular to A bar and B bar? Remove that magnitude, then you will get the vector. So this is a very, very important point, that what is the vector perpendicular to A bar and B bar? That is A bar cross B bar. That is A bar cross B bar. I'll draw the diagram. This is A bar vector and this is B bar vector, right? And this is perpendicular to A bar and B bar, that is A bar cross B bar. Remember, this is a very, very important concept. What is the vector perpendicular to A bar and B bar? Is A bar cross B bar. So therefore, you will have that A bar cross B bar dot A bar equal to 0, because these vectors are perpendicular. And A bar cross B bar dot B bar is also 0 bar. Sorry, 0. Right. So if I ask the vector perpendicular to the vector perpendicular to A cross B and A bar If I ask this question, A cross B and A bar is, you just cross product of these vectors. You just take cross product of these vectors. Cross A bar. Well, angle between A bar and A bar is 0. Angle between A bar and A bar is 0. So therefore, A bar cross A bar is equal to 0 bar. A bar cross A bar is equal to 0 bar because angle between A bar comma A bar is equal to 0. So sine 0 is equal to 0. So therefore, A bar cross A bar is equal to 0 bar. This is an important. Now, A bar cross B bar is equal to minus B bar cross A bar. Nothing but cross product of two vectors is not at all commutative like in dot product. Like in dot product. Right. So here A bar cross B bar is equal to minus B bar cross A bar. How? You see that A bar, B bar and N cap form a RHS, right? This is form a RHS. All right. If we interchange any two vectors, then it becomes LHS. This is the importance of LHS and RHS. Now it becomes LHS, left-handed system. Now, if you replace one vector by negative, then it becomes RHS. Then it becomes RHS. So now it is very simple. So now apply that cross product. Now apply for the cross product for these RHS, that B bar, A bar minus N cap. Minus N cap. Okay. So this implies. Now you see that B bar cross A bar equal to mod B mod A sin theta into minus N cap. Wait. Okay. For the interruption, mod B bar, right? Now you see that mod B mod A sin theta N cap is nothing but A bar cross B bar. So therefore, this is equal to minus of A bar cross B bar. So cross product of two vectors is not commutative, and the order of cross product of vectors is very, very important. There is no order of dot product of vectors. Well, and here is an important that LA bar cross MB bar is equal to LA bar cross MB bar is equal to LM into A bar cross B bar. For example, you take that 2A bar cross minus 3B bar minus 3B bar. This you will get minus 6 into A bar cross B bar. Isn't it? Now you see that angle between I cap and I cap is 90 degrees. Therefore, here you see that I cross I is equal to J cross J is equal to K cross K is equal to 0 bar. Because angle between them is 90 degrees, right? Angle between them is 90 degrees, and X, Y, J are three mutually perpendicular vectors. Done. So along x-axis I cap, along x-axis I cap, and along y-axis j cap, along z-axis k cap. Done. Okay. So here I cross I is equal to mod I into sine 90 degrees into what is the vector perpendicular to I and j? That is k cap. Right. Okay. So here I cross j is equal to k, and j cross k is equal to I, and k cross I is equal to j. I, j, k form a right-handed system of vectors. Form a right-handed system of vectors. So remember that order of vectors is very, very important in case of cross product of vectors. So now what will be the J cross I, right? J cross I. J cross I is equal to C. That is in a left-handed system. You will get minus of I cross J. So this is equal to, you will get minus K. Similarly, you can write rest. Now, the main point we are approaching that how do we find out dot product of cross product of two vectors? This is important. Suppose A bar vector is given, that is A1i plus B1j plus C1k. B bar vector is given A2i plus B2j plus C2k. Well, so before I explain this cross product, I would like to write that distributive law, that A bar plus R minus B bar cross C bar equal to. It obeys that distributive laws. I can do that cross individually, A bar cross C bar plus or minus, plus or minus. Now do with cross B. So B bar cross C bar. This I can do. All right. So here what you have to do is that you have to apply cross product of A bar and B bar. You do the cross with A1i of individual of A1i plus B2j plus C2k. Right? Apply that. Like A1i cross A2i cross is nothing but 0. A1i cross B2j. I cross j is nothing but k. So A1 B2 k. Next A1i cross C2k. So I cross k is nothing but minus j. I cross k is nothing but minus j. So in that way, you have to write all the terms. In general, we get 9 terms, out of which 3 are 0, because I cross I 0, j cross j 0, k cross k 0. And putting together, you will form a determinant. You will form a determinant. So here, how do we write that? A cross B, first determinant of I, j, k, first row. Second row is the first vector, that is A bar vector. And third row is nothing but B bar vector. Well done. Okay. I'll give you one example to explain this. That is important. How to find out cross product of two vectors. Here is an example. What is A bar cross B bar? Okay. A bar cross B bar is equal to determinant of I, J, K. You must be good at evaluation of determinants. Okay. Now, what is the A bar vector? 1, 1, 1. I plus J plus K. And B bar vector 1, minus 1, 1. Now, you just expand this. You will get A bar cross B bar. Right? 1 plus 1, 2i. And 1 minus 1, 0. So there is no j component. And minus 1 minus 2k. Right. This is nothing but 2i minus 2k. All right. Okay. And remember once again, what is I cross I? 0. What is I cross j? K. What is j cross I? Minus k. All right. Here is the most important formula of modulus of A bar cross B bar whole square. Every piece of information and every deduction is very, very important. Modulus of A bar plus B bar whole square is equal to mod A square into mod B square minus A bar dot B bar whole square. Right? Once again, I'll write that formula in bigger way, that modulus of A bar cross B bar whole square equal to, remember, this is a very, very useful formula, mod A square, mod B square. You will understand when I explain the questions. Minus A bar dot B bar whole square. You please see the proof. Proof is quite simple. That modulus of A bar cross B bar whole square is equal to mod A square into mod B square into sine theta. Now you write this sine theta as a 1 minus cos square theta. Sine square theta as a 1 minus cos square theta written. Already written, you see. Now You just expand this. You just expand this. That mod A square mod B square into 1. Mod A square mod B square into cos square theta. Split it into two terms. Okay. This mod A square into mod B square cos square theta is nothing but A bar dot B bar whole square. So that I have written. So this formula is a very, very important. All right. Now, how do we find out that vector area of a closed region? It is very good, right? Very simple. See, this is a closed region. All right. This is a very closed region. You take any closed curve, right? A closed curve. On this closed curve, I have taken 3 points, that is P1, okay, and P2 and P3 in anti-clockwise direction, right? And this is outward drawn normal vector, okay? Like this, a plane is there, and this is the normal to the region, normal to the region. If region is like this is normal to the region. If the region is like this, then the normal to this region. So that now you see that now you just join, okay, P1, P2, and this P1, P3. So here P1, P2, comma, P1, P3, and n cap form a RHS, form a RHS. Right-handed system. They form a RHS. Okay. Assume that area, scalar area of this closed region is D. This is the area of this closed region. So if you multiply to this scalar area by the unit normal vector, then you will get vector area. Then you will get, so vector area. So vector area is equal to scalar area of the region, of the region, of the closed region, okay, into unit normal vector to that region. Unit normal vector to that region. This is known as vector area of this region. This is important. Okay. So now how do we find out that area of triangle ABC? Very, very important concept in three-dimensional geometry and in vector algebra also. Okay. Okay. Right. Try to keep in your mind that area of triangle ABC is equal to half into modulus of AB bar cross AC bar. Here, begin with A. In both the vectors, we have to begin with the same point. Same point. Half into modulus of AB bar cross AC bar. Or if you want to begin with B, BA bar cross BC bar. Right. So proof is quite simple. I don't want to explain here. You just have a look at the proof. If you know little properties of triangle, then easily you can understand. Right. So this is not purpose of giving all proofs. So this here you can see half BC sin A, right? This is the angle A. All right. Okay. So therefore, what is the area of triangle ABC? Half into modulus of AB bar cross AC bar. Please remember this formula. Area of triangle ABC usually denoted by square bracket ABC. This is equal to half into modulus of AB bar cross AC bar. You begin with the same letter. We usually ask a scalar area of triangle. Well, so what is the vector perpendicular to the plane of ABC? What is the vector perpendicular to the plane of ABC, plane of ABC. Nothing but AB bar cross AC bar. Because AB bar cross AC bar is perpendicular to AB bar as well as AC bar vector. AB bar cross AC bar perpendicular to AB bar also and AC bar. So this is the normal to, this is the normal to plane ABC. Plane ABC, or you can say triangle ABC. If you want to find out the unit vector, just divide this vector by its magnitude. Okay, so if you want to find out that vector area of triangle ABC, you just remove the modulus, you just write directly half into AB bar cross AC bar. Well, suppose the sides of a triangle, are along A bar, B bar, C bar. The sides of a triangle of ABC are along A bar, B bar, C bar. Right. Then A bar plus B bar plus C bar is equal to 0 bar. Sorry, here little direction is reverse. This is C bar. So that you will get that A bar plus B bar plus C bar. This is the resultant vector. This is equal to 0 bar. If you take cross A bar both sides, either on the left or right, no issue at all. A bar plus B bar plus C bar. This is equal to right side anyway 0 bar cross any vector is 0 bar. Now you see that A bar cross A bar is 0 bar. So you write A cross B plus A cross C. This is equal to 0 bar. So therefore, A cross B equal to sending that A cross C other side, that is negative of A cross C. If you reverse the order of the vectors, then it becomes C bar cross A bar. So by taking cross A, we got this result. Similarly, by taking cross B, you will get the other result. So that entirely that A bar cross B bar is equal to B bar cross C bar is equal to C bar cross A bar for a triangle ABC. This is also a very, very important concept. And taking cross A, cross B, cross C is a very good idea to get that result. Well, so what is the area of triangle ABC? What is the area of triangle ABC? Here you see, here A of A bar, B of B bar, C of C bar are the vertices of triangle ABC. Are the vertices of triangle ABC. So here this is A of A bar. Well, and this is B of B bar. And this is C of C bar. Origin is somewhere. Okay. So what is the area of this triangle? Delta is equal to half into modulus of AB bar cross AC bar. AB bar cross AC bar. So this is nothing but half into AB bar is nothing but B bar minus A bar. Cross AC bar is nothing but C bar minus A bar. Now do the individual cross with each term. So this is half into modulus of, you see, B bar cross C bar. All right. And minus B bar cross A bar. And minus A bar cross C bar. Anyway, A bar cross A bar becomes 0. You just reverse the orders, then you will get this result. Half into modulus of A cross B plus B cross C plus C cross A. This is also equivalent to half into base into height, modulus of BC bar into height. Right. And also this result, this sum is equal to twice of area of triangle ABC. Just do the cross multiplication. And altitude from A to the BC, altitude from A to the BC, altitude from A to the BC. This is the altitude. All right, is equal to, I want H. So therefore, half of will be cancelled. Modulus of A cross B plus B cross C plus C cross A by modulus of C bar minus A bar. This is altitude from A. So this is the area of triangle ABC. Now, what is the area of a parallelogram? It is a very nice, it is very, very important. So you take that adjacent sides of a parallelogram are A bar and B bar. Right. Well, what are the diagonals? Okay. Or I'll just, you see that this is the diagonal BD. Well, what is the area of triangle ABD? Area of triangle ABD is A bar cross B bar. Area of triangle ABD is area of triangle ABD. Area of triangle ABD is equal to, I can write that half of modulus of A bar cross B bar. Done. So therefore, area of parallelogram ABCD is equal to ABCD is equal to twice this area into modulus of A cross B. So 2 cancel. Therefore, this is equal to modulus of A bar cross B bar. So what is the area of parallelogram whose adjacent sides are along A bar and B bar? Is simply modulus of A bar cross B bar. It is a very excellent formula of area of parallelogram whose adjacent sides are given. There is another formula that when diagonals are given, you see, these are the A bar, B bar are the diagonals of a parallelogram. Then its area is equal to half of modulus of A bar cross B bar. Well, I'll explain that. Here is a parallelogram whose diagonals are given. That is, one is A bar vector, another one is B bar vector. We want to find out that area of parallelogram whose diagonals are given. Well, so what is A bar vector? A bar vector is nothing but P bar plus Q bar. And what is B bar vector? That is nothing but Q bar minus P bar. So, therefore, right, now you see what is A bar cross B bar. A bar cross B bar is equal to P cross Q. Okay. Here we apply P cross Q. P cross Q. Apply individual. P cross P, 0. Now apply with Q. Q cross Q is 0. Minus Q cross P. That is nothing but 2 times of P bar plus Q bar. What is the area of this parallelogram ABCD when adjacent sides are P bar and Q bar? Half into modulus of P bar cross Q bar. Well, this is equal to, right? Sorry, there is no half at all. Just modulus of P bar cross Q bar. But this is nothing but half into modulus of A bar cross B bar. Now, at last, I'm going to explain the solving of a very good repeated vector equation. That I'll explain now. That is most important. Here is a most important vector equation. Solve R bar cross A bar equal to B bar. Well, okay. So here is the solution. The process is important. That you take R bar cross A bar is equal to B bar. Implies taking cross A bar on both sides. Okay. Cross A bar equal to B bar cross A bar. I may be explaining, right? I will explain that later on that how to do this triple product of vectors. Okay. Right now, you just see that this is R bar dot A bar into A bar minus A bar dot A bar into R bar equal to B bar cross A bar. This is very, very important. Assume this is some lambda, that R bar dot A bar is equal to, assume some lambda. So we got that lambda A bar. Bring that RHS wala this side. You will get minus B bar cross A bar. You will get this is mod A bar whole square into R bar. We got it. We got it. R bar is equal to, R bar is equal to, okay, lambda A bar plus A bar cross B bar by modulus of A bar whole square. You will wonder that there will be not less than 20 questions similar to this model. And I'll give you one more vector equation. Like this, they will give you that B bar cross or A bar cross R bar is equal to, or you can say that B bar cross R bar. Well, so what we do, that bring that A bar cross R bar to the left side minus B bar cross R bar equal to 0 bar. Right. We want to find out that R bar vector. So this implies you take that R bar common, then you will get cross R bar equal to 0. Cross product of two vectors is null vector, nothing but they are parallel. They are parallel. So R bar is parallel to A bar minus B bar. Implies that A bar minus B bar or R bar is equal to, R bar is equal to that lambda into A bar minus B bar. So here R bar, A bar, B bar, out of these three vectors, 2 will be given. You have to find out the third vector. Out of these three vectors, 2 will be given. You have to find out third vector. Thank you. Keep watching my channel and enrich your knowledge.